Good evening, everyone. My name is Solomon.
My name is Muhammad.
And this is PatientPro.
So, the motivation behind this project came from the fact that for medical research, oftentimes doctors and residents have to go and extract manually from electronic health records relevant pieces of information for particular metrics and then create data tables from those by hand, which is then used to compute the metrics and do whatever is needed for research and sometimes clinical practice. This is often a tedious and manual process, and that is what we hope to automate and make much faster via the use of large language models such as GPT and PatientPro. So our largest challenge for this was actually getting our hands on some quality data. So EHRs are considered protected health information, which means they make you jump through a lot of hoops just to get your hands on one. And there's a lot here that we mentioned, places that we tried to contact, and initially that took a very long time, which kind of forced us to resort to using synthetic records in our first phase, just with our first metric. And so we had to do that for our Centaur score, which we'll talk about in a bit.
And that's an example of a synthetic EHR. That's an example of a real EHR. So eventually we gained access to Mimic4 Note, which is a huge data set on PhysioNet, consisting of de-identified free text clinical notes. Of that big set, there's an ICU note subset, which is about 2 million items, and 140,000 of them are doctor's notes. We extracted 18 records from those for our Q-SOFA score, which we'll talk about in a sec, and that was our test set. And for pre-processing, we just saved them individually as files and assigned them names for proper integration with our system. So the labels for our data are the data tables themselves. Obviously, they don't come with the data sets, so we had to manually create them, and we got those verified by a subject matter expert. These are the labels for our test set for our second metric, which is the Q-SOFA metric.
So, about the metrics, which we've kind of referenced a couple of times, for our first phase with the synthetic data, we actually used the Centaur score, which is the likelihood of strep in people or patients that have sore throat symptoms. It looks at a few data points that are mentioned over there. Once we got the real data from the Mimic data set, which was ICU specific, we looked at the Q-SOFA score, which is the likelihood of patient mortality when you suspect that they have sepsis, and it looks at these three data points.
Right, and well, we chose another metric because we wanted to generalize and show that it could work for more than one. So for our phase one, which was when we were using our synthetic records, this is what our system architecture looks like. So before it starts, before the main flow starts, we start with our generation submodule. The prompt is quite straightforward. We say, take a look at this seed record, give us something like that, and vary the data a little bit. And then GPT-4 outputs several synthetic EHRs, which we then populate the data set of the main flow with. And then from there, our system prompt describes what to look for the specific metric, the specific pieces of information, and how to create the actual data table, which is just simple in JSON format. We have the option to few shot prompt it, with labeled samples, and in our context, we have our unlabeled sample. And again, the output for the system is just the data table, and just for good measure, we included the functionality to compute the score. And for phase two, after we got the Mimic4 Note data set, we were just able to use that instead of the synthetic records, and everything else is basically the same.
So how do we measure success in this case? In this case, success is considered extracting all the relevant data correctly. Anything else we consider a failure for that particular instance. And so this score is a binary pass-fail for every record that, or every EHR that's passed through the system, and that's due to the kind of sensitive nature of this data. You can't really make mistakes with this. So for our synthetic EHRs with the first metric, the Centaur score, we had a basically 10 entry data set, and we attempted from 0 shot, which means with no worked examples, all the way to 3 shot. For 0 and 1 shot, we got a 90% success rate with 1 failure in one of the doctor's notes, and then with 2 and 3 was 100%, caveat being that synthetic EHRs are short, simple, organized, and they don't really represent what a real EHR looks like. With real EHRs from Mimic4, we got 87% or 86.7% success with direct 0 shot, and with 3 shot we went up to like 93%.
And I'll get to that caveat in just a second. So overall, PatientPro performed quite well with over 85% accuracy in all tests. Results did improve past 90% with few shot prompting, but it's still pretty good in direct mode, which is great because we were really racking up a lot of tokens because of how long these EHRs were for the QSOFA one with the real EHRs. And something that we noticed that was really interesting was that PatientPro actually performed better on qualitative metrics and qualitative items rather than quantitative numerical values. And we had anticipated that it would have problems with the altered mental state field for the QSOFA score, but with little prompt engineering, we got that out of the way. And the real issue was that multiple values may exist, may be reported in the same EHR. So that was what we sort of got stuck on.
What we do better next time would be fine-tuning a GPT-4 model, given more time and more resources to actually label a lot more documents. That hopefully would solve that problem of multiple values throwing it off, or eliminating them entirely via cleaning up the data. And that would be all. Just a few seconds short, but thank you for watching.